All right, so here's the deal. We just did our paper passing out. On your paper, page 1 up at the top here, I just scanned actually these pages because they're slightly different than my old document. This could be very similar. How fast is our class? Now, before we get into this, we need to know some terms. And here's the deal. When I first started teaching Eureka, I made PowerPoints, and I tried making PowerPoints for every lesson. Then I found, number one, I couldn't keep up because every day we're doing a new lesson. But number two, kids were like, where do I write this? What do I do? So I just used the PDF of your book. You write whatever I write. Okay? Now, I might mess up from time to time. Again, when I'm writing, am I looking down at what I'm writing? No, I'm actually looking up here. So it's kind of tricky when we're doing it, but I got to look up here, even though I'm facing this way and stuff. So oftentimes I sit in the back and I write that way. But you write down anything I write down, okay? And just mimic what we're doing. So, some terms. A ratio. Let's have you circle the word ratio on page 1. One of the things about Eureka that I questioned at first was their complicated language, okay? The words, it's tough. But here's the deal. If you use complicated language, if you're experiencing complicated languages, what are you going to be better at in the future? Understanding, yeah. So really, I'll try and break down some of the ones that are really kind of confusing. They say a ratio is an ordered pair. How many? 2. 2, a pair, right? Of numbers which are not both 0. Here's the deal. If you had a 0 in both of them, it would be 0 to 0. That's not a ratio. And really having a 0 in the numerator means like there's no relationship, and a 0 in the denominator is bad, okay? So here's the deal. Just can't have both zeros, all right? Now, a ratio is denoted, that just means the way we show it, when we have A and then colon B, okay? That's one way to show it. We're going to look at 2 other ways. And it says to indicate, which shows the order of the numbers. The number A is first, number B is second, right? Does that make sense? A to B. We're talking about A first, then B. Now, this one's kind of complicated, but it's not that bad. 2 ratios, A to B and C to D. Notice what I'm saying instead of the colon. What word did I use that's also like a number? 2, right? So our equivalent, what does it mean if 2 things are equivalent, the same or equal, right? If there is a non-zero number C such that C equals C times A and D, notice capital, lowercase, C times B. That's kind of confusing, but it's not that bad. For example, 2 ratios are equivalent if they both have values that are equal. So if I wrote down the fraction 1/2, undo. If I wrote down 1/2, so you write down 1/2, you don't have to write that there. 1/2 equals 3/6. Are those equivalent ratios, which are also fractions? Yes. Now, you know it for a couple different reasons. One, you could use a calculator, take 1 divided by 2 and 3 divided by 6. What is their decimal equivalent? 0.5. Very good. So we know they're the same decimal. But also, this is what they're saying here. If I multiply this number times something, I have to multiply that number times the same thing. What times 1 is 3? So this would be like times 3. If you have room to write it there, that's good. Sometimes I write bigger so you can see it. And down here, this would be the same. Is it the same number that we're multiplying by both? Yeah, and that's like that little C right there, okay? Now, a ratio relationship can occur between 2 types of quantities. We call these rates, okay? And we could talk about 5 miles per 2 hours. That's a rate of speed, right? What is your official rate of speed on the interstate? You know what the speed limit is?
80 miles.
80, you're going too fast. 75, okay? So 75 miles per hour on the interstate, that is a rate of speed, right? We could also go to a store and you have a rate of buying something. I was at Walmart and Target last night, and I saw they, in both places, had tons of masks. I saw Chaz there too. I didn't recognize him at first, and I saw that mask. Looking good. And I didn't have a mint. But anyway, here's the deal. They have masks. Now they have supplies of them, and they were selling them at different price amounts per mask. And if you can figure out a rate or unit rate, you can figure out which one's better buy. Okay? So we can talk about rate of speed. We can talk about amount rate at a store. Now, this is where it's different than what I've done for most of my teaching career. The numerical part of the rate, which is just the number part, is called the unit rate. And it's simply the value of the ratio, in this case, 2.5. And I like the label on there, but they don't always label. I like that it would be 2.5 miles per 1 hour, okay? But we're just going to look, when they talk about the unit rate, that is just the number, okay? So now let's start filling in the table from our values. We had 24 papers passed. And so this is 24 down the line. And then here we had 60 seconds the first time. We dropped it 11 seconds to 49 seconds. Our third attempt, we dropped it over half, 25 seconds. Then our last one was 17 seconds. And notice it says seconds, so you don't have to label it here. But we know these are seconds. We know these are papers. Okay? Now, for ratios, we looked at one way you can write them, but there's 3 ways. So there are 3 ways to write a ratio, to represent a ratio, and there's actually more. There's some words that mean the same that we'll see and experience. The first way is the way they did it. What they use? Or the dot dot. What's dot dot called? Colon. Very good. So we could say 24, and it says the number of papers, so that's first. 2, which is the colon, and how much time did we take here? 60. That's one way to write it. Instead of the colon, what word did I use? So I could do 24 to 60. But then my favorite way probably is this. What do we call this type of number? A fraction. A fraction is a ratio. And what can we do with some fractions? We can reduce, right? We can simplify. Most of the other classes, they couldn't reduce. Yours could, but we're not going to worry about that right now. Okay? Now, the rate is going to be what I call a reduced rate. They don't always use this number, but I call it a reduced rate. And what we're going to do is take 24 divided by 60. Okay, so now we need the calculator. Go to your calculator, type in 24 divided by 60. It's in the order that they showed up.
I wonder what the two
0.4.
All right, 24 divided by 60. You got exactly 0.4. Nice. Most classes got an ugly decimal number that filled up their screen. So here's the deal. It's 0.4, and then we got to label it when we talk about the rate. And this would be papers per second. Okay, now here's the deal. If you do PPS right away, do I know what you're talking about? PPS? No. So we could label papers per second now, but in the future Carter Perfect, we'll label it, we'll shorten it up to PPS. Okay? But if I don't know, like if I said MPH, do you know what that means? Yeah, that one we know, but really if I said KPS, you'd think school system, but it's really kilometers per second, okay, or whatever. So if you don't know what it is, write it out first. Now, let's go to this one. The second time you did it, you only took 49 seconds. What's 24? We could do it the 3 different ways again. What's 24 divided by 49? Raise your hand when you have it in your calculator. 24 divided by 49. Chaz, nice and loud. And we're going to round it to the nearest thousand. So it would be
0.49.
0.4. Actually, yeah, this one's tricky. So it'd be 0.490. Since it's 89.7, right? You see the 897. The 7 tells the 9 to go up, but the 9's already at the top. It goes up even more. And I put it in the wrong spot. So there. 0.490. Now we can do PPS.
Wait, why is it 4.499?
If you look at it, it's 0.4897. Is that correct? The 7 tells the 9, hey, you got to round up. I'm over half. So the 9 would round up to 10, which would bump a 1 to the other 8, making it a 9. And just think, what does 89.7 round to? Round up 90, right? So that's where we get the 90. Okay? That didn't show up in any other classes.
So do you need the zero there, or is it just?
And here's the deal. Do we need that zero? And I say yes. Since I told you to round to the nearest thousand, did it come out exactly? No. So that zero actually tells a mathematician that it wasn't exact, but it rounded to it. Okay? Normally, if I said round, if I didn't say round, but it was like 0.49, you don't need to put a zero on there. Great question, Chaz. In this case, since I said round to the nearest thousand, putting it on there tells the person it wasn't exactly, but we rounded to the zero. Okay? All right, let's do 24. Oh, we're so close. What's 24 divided by 25?
0.9.
Dane, what do you get?
9,600.
0.96. And it comes out exact?
Yep.
Yeah, that's nice. Because 25 goes into 104 times 24 times 5, 0.96. Your numbers came out pretty nice. Do we need a zero on this one?
No.
No, because it came out exactly 0.96. And that would be PPS. What if it took us 24 seconds to hand out the papers?
That would be 1.
Yeah, it would have been 1 paper per second is what it took us. Okay? All right, now let's look at this last one. Take 24 divided by 17. 24 divided by 17, we get 1.141.
So 1.4.
1.41.
141? 1.4. And does it round? Let me see here.
Yeah, rounds up to the
Yep. The 1 goes to a 2. Perfect. Is that right? 1.142? No.
1.4.
Let's just erase all that. It's so tricky. Nope, that's what it is. 1.412, right? Is that right, rounded? Okay. And again, I don't know these numbers. These are different every class. So now, here's the deal. Do you want a bigger number or a smaller number to be more efficient? To be more efficient, what number are you looking for? A bigger number, okay? As we got more efficient, our number increased a little bit every time. And you barely beat 7th period, even with people messing around. Oh, you recognize that guy?
Yeah.
That's funny. Thank you. You got a bookmark in there. All right. So down at the bottom, there's some space. We're going to take some notes. Okay? Right here. And again, everything I write, you write. First thing, we're going to write ratio. Okay? There were 3 ways to write a ratio. What was the way they showed us initially? What they used? Colon. So here's it. We're going to use a little algebra here. We're going to say A colon B. That's one way to write a ratio. Or what can we substitute in for the colon? What word?
2.
2. Perfect. So we could say A to B. Or what's my favorite way? As a fraction. Very good. So smart. A over B. 3 ways to write a ratio. Okay? Now, ratio labels are important, but not that bad. We just say a ratio of whatever to whatever. Okay? And we can turn it into the unit rate. Well, what we're going to do then is take a step up. A rate has labels. Okay? And again, we talked about like a rate of speed. We could say the amount that you pay at the store is your price rate. Okay? Let's say we were traveling along. We went 150 miles in 3 hours. Okay, that's a rate of speed. Now, how fast are you going? Are you going super fast, kind of fast? Kind of fast. Are you on the interstate?
No.
Probably not. Are you on a car or on a horse?
No.
On a horse? No. Are you in an airplane?
No.
Are you in a car? Probably in a car. Are you on gravel roads?
Yeah,
Probably not.
my dad flies
No.
75.
Should not be going that fast. Might you be on like a highway driving along? Yes. Now, here's the deal. The speed limit between here and Grand Island, for the most part, is 65 miles an hour on Highway 30. Okay? But would you be able to maintain that speed the entire time of going 65 miles per hour?
Not exact.
No. Why can't you maintain that speed of 65 miles an hour? Even on a good day with hardly any traffic. What's in between here and Grand Island? There's towns. Very good, Skylar. There are towns, and you got to slow down for the towns, so your average speed goes down a little bit. Okay, so let's say you're driving around, you go 150 miles in 3 hours. I want the unit rate. Okay? What am I going to do in my calculator or in my head? Sometimes you can do it in your head. Yeah, divide it out. 150 divided by 3. What's 15 divided by 3? 5, and there's a 0, so it'd just be 50. Now, what the book says is that's good enough. Okay? They say 50, that's your unit rate. But I like the label on there. 50 what? And do I have to write it out?
No.
If you see MPH, do you know what we're talking about? Very good. All right, next example, let's say we're at the store and we can buy for $10. We get $10 for 4 pounds. Okay? $10 for 4 pounds. That is a rate, right? Now, what would the unit rate be? Well, I take the dollars divided by the pounds. 10 divided by 4 is 2.5. Now, again, 2.5 doesn't make a whole lot of sense. I like the label to go with it. Later on, though, it's that number we're going to tie to something else that's important. What is my label for this, Miles? Yeah. Dollars. And notice I do a little there. Per. And then pound. LB we could do for pound. Dollars per pound. Okay? Does that make sense?
How do you have $2 and $2.5?
That's $2.50. Now, normally, what do we do with our dollars and cents? What do we round to?
Put it at 0.
Yeah. So in this case, yeah, this is like we're talking about that 0. Good point. I like that. But really, they would say 2.5 is good enough. But if I label it as dollars, some restaurants think they're fancy and they label it like this, but I find it annoying. I want that 0 there. But here's it. Maybe they're saving on ink. They got to pay for so much ink. Think how much ink you would save by not putting a 0 every time you printed a menu. Okay? So, I don't know. But yeah, when we're talking dollars and cents, I label it. I love that 0 there. Good point. Okay? All right, does that make sense? Good. So we're talking about ratios. We're talking about rates. We elevate a little bit, and then the unit rate breaks it down. And we're looking at like how much it is for 1 hour, how much it is for 1 pound. Now I can figure out, what if I buy 7 pounds? How much does it cost? With the old way, 4 doesn't go into 7. That'd be kind of tricky. But when we find the unit rate, then we can bounce to other things. Okay? Next. They want to know the class by gender. Okay? So right now, let's have all the boys stand up. And I need to know how many boys are in the class. How many boys are in the class? Help us count out here.
No.
Good. I think everybody's standing up. Miles, how many did you get? Oh, you're counting now? How many did you get?
More than 11.
More than 11.
13. Are we counting you and Mr. Ricky?
Oh, great question. Are we boys? I know we're men, but would we count as gender of boys? Sure. So how many would that be?
But women.
15. I know, we're all men, aren't we? So that'd be 15 boys. Go ahead and sit down.
I'm not.
You count them?
I did not count.
I counted 15 twice.
I kind of like how
Let's stand back up. We got to learn how to count. Let's count them. Maybe somebody wasn't standing up when they needed to. All the boys.
1, 2, 3, 4, 5, 6,
16. All right.
11, 12, 13, 14.
What? 2, 4, 6, 8, 10, 12, 14, 16 is correct. I trust you to be able to count. So now, without having to have the girls stand up, knowing what we know from the papers, how many girls are there in this class?
No.
8?
No, because you have to
8, right? Oh, good point. Yeah, so here's the deal. Who did not participate in the paper handout? Us too. So there's really 14 that did it here. We know there's 24 total, so it's actually 10. And if we were to count the girls, we would get 10. But here's the deal. If you know the total amount, you know whatever one part is, you don't have to count the other part, okay? And again, this one could reduce. We could have 16 to 10. What's another form of 16 to 10? What goes into 16 and 10?
8 to 5.
No, we're doing all.
Oh, all.
Yeah, all. It would be 8 to 5, right? What is 8 divided by 5? 1 remainder 3. 3/5 is the same as 6/10, so it'd be 1.6. So what this is saying, for every 1.6 male, there would be 1 female. Okay? For every 1 female, there's 1.6 males. If I switched it around, does that make sense? So that means there are more males in here than females. Exactly. So that's another good point. Males, you need to be wearing deodorant. All right? You need to be showering. Help us out. Keep your arms down. All right. So